there any questions?
I have a question about, if we can go over a similar question as one master set for
Sure.
number 9.
This is 22.
Yes.
The 4 wires are running parallel.
Yes.
That one? All right. Nope, not that one. Oh, it is that one. No, it's not. Let's see what happens. All right. So 4 wires are running parallel at the corners of a square. The wires run parallel to the x-axis and hit the YZ plane at. All right, so first let's set up a coordinate system. Hey, there happens to be one right here. All right, so it's hitting the YZ plane at these coordinates, so let's just go ahead and establish some sort of convention here. So let's make that the y-axis and the z-axis. If that's the case, the x-axis is either running out of the board or into the board. In a right-handed coordinate system, which way would it go? How'd you come up with that? You just know it, or you took a shot? Okay. The other way of doing it is that in a right-handed coordinate system, if we put I hat in the x direction, then that's I hat y, j hat. I hat cross j hat is equal to k hat. So basically it's running in alphabetical order. So I have the y and the z, j hat cross k hat, go around the corner, is equal to I hat. So j hat cross k hat will give me I hat, which is out of the board. All right. So it hits the YZ plane at 0, 0, 10, 0, 0, 10, and 10, 10. So if that's 10 to there and 10 to there, obviously not on the scale. Matter of fact, we've got a grid here, so why not? So let's say 2, 4, 6, 8, 10. So let's make that 10. And we'll make that 10. So it's going to hit this YZ plane at there, 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 and there. So I got 4 wires that are coming straight out or going straight in, depending on the way you want to look at it. Magnitude of the current running through all 4 wires is the same, but the direction of the current is as follows. The first 3 have current running in the positive x direction. And the last one is in the negative x direction. So the last one was this one right here. So this current is running into the board. This current is running out, out, and out. What's the main direction of the total magnetic field at the point 5, 10? Now, the reason why it's worded like that as opposed to what's the direction, one, it's a conceptual question, and although you could solve it with the knowledge, with the information I've given here, but it originally was a multiple choice, and I had limited arrows to put in the multiple choice, and so that's why I said the main direction. So it comes down to, if I have a current that is running out of the board here, what is the direction of the magnetic field it creates? And I will say to the two of you, it's a right-hand rule. So I'm getting a number of people who are putting their thumbs in the correct direction. So what would be the answer?
Counterclockwise?
Yeah. So the magnetic field is running around like this. So fingers curl this way, and so it's going indeed counterclockwise. If I've got, so if I have a current flowing out here and I have a current flowing in here, what's the direction of this magnetic field? Sorry, in here. So the current's flowing this way. I think a couple of people have it, they're just afraid to say it.
Clockwise?
Yeah. It'll be flowing around like this. Thumb points in, fingers curl in a clockwise direction. So the way I've drawn it here makes it look like I've just got a magnetic field here, but I can really have a magnetic field here, coming around. And then, since we've somewhat color coded, it's so I have these two competing magnetic fields. In this particular case, where is the total magnetic field going to be the strongest?
Is it gonna be directly in between the two of them?
Why?
Because that's the only place where they're going in the exact same direction.
Yep. So here, the magnetic field is that direction. What about over here? What's happening over on this side? So you're pointing upwards.
Counterclockwise?
Well, at this point, I'm just looking at a point here. So up, I'm fine with that. Is the magnetic field here stronger? Is the magnetic field strength stronger here or here?
In the middle,
Why not over here?
because they're going opposite directions.
Okay. Now, recognize it's not a complete canceling out in this particular case because the green line is farther away from the current, so this is a weaker magnetic field than this is. The brown is closer to its source, and that was originally brown, so it was. The brown is closer to its source over here, so it's a stronger magnetic field upwards than the magnetic field going in the opposite direction over here. So ultimately, it is going up, but not as strong. If that distance and that distance are the same, but that distance and that distance are the same, then it would be up and then weaker than it is here. So in essence, on the problem over there, you're basically doing a right-hand rule, figuring out at the point, what's 0, 5, 10?
Yes.
And then figuring out what is the direction of the magnetic field from each of these sources at that point and what's going to cancel out. Or more importantly, what doesn't cancel out? So if we did that in the middle, the magnetic field's, and again, we have a grid here, so, that would put it there. Apparently I touch it more than I think. Okay. So from here, the magnetic field is going like this. Well, something that will show up. So from here, I have a magnetic field that's going this way. From this one, I have a magnetic field that's going this way. From this one, I have a magnetic field that's going this way. And from here, I have a magnetic field that's going that way. So in this particular case, this is not the problem I don't think it's the problem. No, this is not the problem in the master set, but for this case right here, what would be the direction of the magnetic field? And I saw 2 fingers in the correct direction there. 3. Can I get a 4th? So basically we have a divide here of, all right, can we have a 4th from this group? Pointing in the direction of the total magnetic field. There we go, we got 4. Yes, that way. These cancel each other out, those two boost each other, so it's in that direction. That's the one I want. Gina, did that answer your question?
It did.
Okay. Other questions? Or follow-ups? Sarah, you keep sort of trying to look around the tubes here.
It's okay.
Oh, there's water there, so I guess I can't push it properly.
I guess if you add number 10 to it, since that one is asking about force instead of magnetic field.
All right, so in 10,
What is that difference?
so this is just asking at a different point. So in 9, it's asking about the point here. So 9 are, yeah, problem 9 is there. 0, 10, 0, so problem 10 is there. And why 13 is separated from 9 and 10, I don't know, but 13 is asking about this point right here. Halfway between is there. At least on the version I have.
Answer to the example problem we did, would you just want an arrow pointing in that direction, or would that be like the positive Z direction?
It's not, positive Z is straight up, because this one happens to be at a 45-degree angle, just an arrow is fine.
Okay.
And would you want us to explain, since I know it's a conceptual question type?
It does say explain, so I'm expecting more than just an arrow for the answer. See, is there any difference between 9 and 13 other than the location? Oh, there is. In 13, I'm actually asking for something more specific than an arrow. In 9 and 10, I'm asking for the main direction, so an arrow is fine, but 13, I'm actually asking for math to be done. Oh, there's a backside too. Okay, that explains that. Yeah, probably should relabel that since 13 is not a conceptual question anymore. Or, I guess it's half conceptual. No, 13 is a math problem. Questions?
Could we add math into your example problem?
Well, because of the symmetry, it's a lot easier. So the quick and dirty for this particular example problem would be the direction, given my ijk there, it would be square root of 2 over 2 k hat minus square root of 2 over 2 j hat. Ah, that's so clear. All right, let's talk a little bit about why is it square root of 2 over 2. This is pointing in that direction. I know it's at a 45-degree angle in this particular case. And so it is, I'm going to the left and I'm going up. To the left would be the negative j hat, up is k hat. So that's why there's a negative j hat and a k hat. Typically written in different order, but hopefully this suffices. So let's assume that I write it down as just a direction. I know that it is in that direction. And when you're indicating direction, you typically use a unit vector. In other words, the magnitude of my answer, and I'll just call it a hat, is 1. Using a for answer. So I know it's going to the left and it's up, it's a 45-degree angle. So negative 1 j hat plus 1 k hat, that puts me in the right direction, but that doesn't really, that's not a unit vector. How would you find the magnitude of this vector here? It was a long week, wasn't it? I know, I mean, a week without having interaction with other people talking about physics, it's like a day without sunshine. And you find the magnitude of a vector.
You add them?
The question,
Find the
how?
resultant vector?
Okay. So I'm going left 1 and I'm going up 1. How would you find the magnitude of the resultant?
A squared plus b squared equals c squared?
So that would make this square root of 2. So if I take any vector, I can turn it into a unit vector just by dividing by the magnitude. So that over the square root of 2, that over the square root of 2. We can generalize this that a unit vector is just the regular vector divided by the magnitude of that vector. And so if I have 1 over the square root of 2, if I rationalize the denominator, because that's what the math people like, you get square root of 2 on top, and on the bottom you get 2. That's where the square root of 2 over 2 comes from. However, we'll do something more sophisticated in just a moment here. Questions about this before we look at something more sophisticated? All right, let's be more sophisticated. Let's take a point. Oop, apparently I'm still erasing. What's the direction of the magnetic field at that point right there? Well, the direction of the magnetic field, we'll take each piece by piece. First off, what is the formula for the magnetic field because of a current?
Are you talking about the formula?
Yeah. Sorry, let's be more specific. The formula of the magnetic field because of a current along a straight wire.
Mu times current divided by 2 pi r.
All right. Just as a contrast here, I guess that would be the magnitude of it. So this is the current from a straight wire. The 2 pi r comes from the fact that if